Okay, so we'll start with a geometry network. I'll call it sim. I'll change the color and we'll dive inside. We'll start with a grid here, and this grid will change the size of it as 4 by 4, and we'll change the rows and columns to 2 by 2. Okay, so we have a grid with 2 columns and 2 rows. We will remesh this as we are going to need a lot more points, a lot more triangles here for a proper Vellum simulation. I'll change the target size to 0.02 here in the remesh, and this is going to give us a lot of points. I'm just preparing for my final render, and that is why I'm using a UV flatten node so that we have a proper UV setup for this geometry, for this grid. I'm going to use a group node here, and I just want to group all my outer edges here. So I'll just change it to pin, change the group type to points. I'll turn this off and I'll come to include by edges and turn on unshared edges. This way I'm going to get all the unshared edges or the outer edges of this grid and this group called called pins. I'm going to use the poly extrude node now, and let me just turn on the output back here. I'll turn on all the groups as well. Alright, so this is our output back, right? Let me just turn it off. So when we use our distance here, so the distance is going to be around 0.1. So this is our distance, and I'm just going to increase the division number to 3. So when we look back, I have turned on the output back here. If I turn it off, you can see that there's no back here to this extrude. So I'm just turning on the output back here for those purposes. And I turned on all the groups here as well. This is the front group, this is the front group, this is our side group, and this is our back group. Okay. So after this, what I'm going to do is I'll just use a so I'll use a group promote here, group promote node, because all the groups that we have created in the poly extrude are actually primitives. So let me just turn them to point groups, and I'm selected all the extrude groups here. And now that they are point groups, we'll be able to use them in our Vellum constraints. Okay, so after group promote, I'm going to use a null. I'll call it out. This is our null. And after this, I'm just going to use a file cache node just to make sure that we have cached our geometry that we have created. And I'll just turn off the frame range here. And one more thing that I'm going to do is I'll just save to disk. Okay. So this is our geometry now, and what we can do is we can apply our Vellum constraints. So I'm going to apply a Vellum balloon configuration. We'll start with that, and in the Vellum balloon configuration, we are going to get Vellum cloth constant and Vellum pressure constant. Let's just connect that to our Vellum solver. Okay, so now we have our Vellum cloth constant and our Vellum balloon constant. So this is a Vellum cloth constant. I'll change the group type to points here. It's not really going to affect our simulation at this point, just adjust that. I like to do that. This way we can apply group points here. So this is our pin to animation, and we want to pin our certain groups that we have created. One of them is the output back, output side, and the pin. So we are going to create output back, select output back, output side, and let's select the pin group as well. And this is going to be our stretch section of our cloth constraint. So Vellum cloth constraint gives us two important which are our stretchability of the cloth and the bendability of the cloth. So we control how bendable the cloth is going to be and how stretchable the cloth is going to be. So this stretch section controls how stretchable the cloth is going to be. If the stiffness is very high, that means the cloth is going to be less stretchy. So I'm keeping the stiffness at 1E plus 8. And in the bend section, we control how bendable the cloth is going to be. And if the stiffness is too high, then less bendy. If it is low, then it is going to be bendy. So I'm keeping the stiffness to 0.001. And this is a pressure constraint. I'm just changing the group type here. Let me work with the stretch section here. The stretch section in the pressure constraint controls and maintains the amount of pressure inside of a mesh. Okay. So if the stiffness is too high, that means we want to maintain a good amount of pressure inside of a mesh. Okay. Stiffness maintains the pressure, and we can use our output group here. This will be particularly useful when we animate our rest length scale inside our Vellum solver. Okay. So the stiffness controls or maintains the amount of pressure, and the rest length scale generates the amount of pressure inside our mesh. Okay. So if I increase this rest length scale, when it is 1, it means the amount of pressure inside of our mesh is going to be 1. And when I increase it to something like 6.5, that means the amount of pressure is going to be 6.5 times of its volume. Okay. So that is that. And if I play this now, let's see what is going to happen. Okay, so this was our simulation as you saw. This is what we are getting. The bottom parts are all bent, and the front group of our geometry is actually simulating. Because there's pressure inside, it is moving like this. Okay. The pressure always is 1, and on the second frame it is increasing to 6.5 as we have set up the rest length scale to 6.5. That means the pressure is increasing by 6.5 times. Okay, so this is our simulation result, and what we can do now is we can use a collision here. Okay, and as you can see in our preview, for the collision, what I've used is a Nike logo. So let's get to that. We'll start somewhere here by creating our geometry. Let me just align this properly first. And okay, so we'll start with the grid here. This is our grid. And let me just decrease the size here to something like 1.024, and the y is going to be 0.534. Okay. So this is the size of the grid because the size of the image that I'm going to be using for the logo is something like this. Okay. So what I'm going to do is I'll just move it a bit up. 0.11 will be nice, and what I'm going to do is I'll just straight away increase the rows and columns to 1000 by 1000. Okay, we need a lot of geometry here, a lot of points here, because we'll be using a attribute from map node, attribute from map, and with the help of the attribute from map, we will be creating our Nike logo. So I'm just bringing in our Nike logo that I've got from the internet. I'm just inverting this, invert V, and this is what we're getting. Okay. Okay, so after bringing in our attribute from map, what I can do is let's just make it float instead of vector. So this is what we're getting. We have black area in the image and the white area in the image. So what I want is I want to delete all the black parts and I just want to keep the Nike. And this is what I want to keep. Okay. I'll just come to our source color space here. I'll change it to linear. This isn't going to really affect a simulation or the image, so don't worry about it if you don't want to change it. I'm just going to use a blast node here, and I want to delete all the black areas of this grid. So I'm just using a code cd equal to 0. So all the points with black areas will be selected and will be deleted if I change the group type to points. So this is what I'm getting. This is what I'm getting, and what I can do now is I'll just extrude this geometry and this will be able to use it later in our Vellum simulation as collision. So I'm using a poly extrude node. Okay, I'll just extrude it to something like 0.125. Maybe something like 0.1. Actually, let me just watch it from here, and I'll just put in specific now, 0.125. Okay, so this is what we're getting, and I'll just turn on the output back. So we have a back here for our extruded geometry, and let me just turn on the divisions to something like 8 or maybe 10. Okay, I just move it to 11. After this, what we can do is, let me just use a reference here. So this is our geometry, this is our cloth, and what I want to do is I want to properly scale this so it is comparable. So I'll use a transform node, and let me just increase the scale to uniform scale to 2.5. Okay, so I increased the scale by 2.5, and if I see, okay, this is not touching it, let me just bring it down a bit so that it is touching the upper part of our mesh, something like this. Okay, because we want to create another group here which will be pinned. Okay, so let me just move it down, and I'm going to use, let me just close this. I'm going to use a group node here, group. Let me just connect it to here, and the next thing that I'm going to do, here, the next thing that I'm going to do is I'll just connect the second input here to our transform. Okay, so now that we'll be able to create a point group, I'll call it logo, or you can name it whatever you want. I'll just turn it on, and I'm going to use a keep in bounding region and bounding object. Okay, so this is going to be our bounding object, but it is not working. And why is that? Why is it not selecting any points? Okay, so there must be some mistake. Let me check. Okay, so this is colliding with our geometry, but for some reason it is not working. If I change it to box, it is selecting. If I change it to our logo, it's not working. I'm just keeping it here, this mistake, so that, you know, sometimes I'm pretty sure this is going to be a very, let me just delete the CD here, attribute delete. I'm pretty sure this is going to be a pretty simple mistake, and so why is it not working? Bounding box is working, bounding sphere is working, but our bounding object is not working. Okay, let me just see. Okay, so is this colliding? Okay, so here's what the problem is. This is not colliding with our front because we need to put poly extrude before here. Something like this before the group, okay? So that when it is extruding, our front portion is going to get up. So it wasn't actually colliding with our geometry. And now what we can do is we can come to our cloth and I'll select the logo and I'll come to our Vellum solver and run the simulation and see. Let's run this and see if it is working. Okay, so clearly we can see that it is not working. What is this? You just close this. Okay, so you can clearly see that this is not working and we have applied our logo group here. So the group is working fine. This is our logo group. This is our group promote, but we don't need to promote our group, that group. So we have our logo group here in our point section. Okay, and this is points. This is working fine. So all these points should be pinned to their place. They should not be taking participation in the simulation as we have set them as pins. Okay, so here's the problem. In our file cache, the logo group was not there. So I'm just saving it again and see that the logo group is working, and now we have our logo group. Okay, so now this should be working fine. Let me just run this and see what is the result. Okay, so now that we are running our simulation, we should be able to see on the second frame that, okay, it is working. It's working fine. The simulation is working fine. The Nike logo that we are using to create a group called pins, which we are using as pin group in our Vellum cloth, they are pinned. Okay, they are not taking participation in the simulation, and you can see this is that. And what we can do is, along with using the Nike logo for creating a pin group, we can also use this as our colliding geometry. So I'll just, instead of this, I'll just template this. Okay, so let me just use this Nike geometry and I'll move it up a bit so that it is not colliding with our geometry, something like this, and I can use it as a collider for our Vellum simulation. Okay, maybe something somewhere here, so that maybe up a bit. Okay, so now I can connect this logo or Nike geometry into our collider, and let me run this. So this is going to behave as colliding geometry for our cloth, for our sim, and let's run this and see what we are getting. Okay, I think I have run my simulation enough and this is working perfectly fine, behaving as a collider just like we wanted. And what we can do now is we can improve it a bit by, instead of creating the pressure on the second frame itself, what we can do is we can increase the amount of pressure inside of our mesh as we progress, as the simulation progress. Okay, so we can animate the wrestling scale inside of a Vellum solver to get that effect. So do that, and I think that would probably give us better results. So this is looking nice. Okay, let me just go to frame 1 and I'll dive inside of a Vellum solver. And here what I'm going to do is I'll just create a Vellum constraint properties node. Let me just turn this off so that the simulation is not working. Okay, now that we can see our geometry, let me just create a Vellum constraint properties node. And we will animate our wrestling scale for our pressure constraints. Okay, so let me just create the group here, and as you can see there's no group here because we have turned off our brain, our simulation here. And if I check now, I think I'll definitely get our stretch pressure group which we created earlier while we were working on our pressure constraint. Okay, so with the help of the stretch pressure group, we will be able to manipulate our wrestling scale only on the pressure constraint. Okay, so here in the pressure constraint, you can see we have created our wrestling scale to be 6.5 on the second frame. So I'll just change it to 1, and we have our output group called pressure, so that we can animate this wrestling scale inside of a Vellum solver and properly animate it. So I'll just turn this off. On frame 1, the wrestling scale is going to be 1, and I want to increase it to 6.5 at around frame 35. So I'll create another keyframe here at frame 35 and increase the value to 6.5. So as you can see, as the animation or as the timeline is progressing, the wrestling scale is increasing to 6.5. I'll just turn this on, and we can run this simulation now and see what we are getting. Okay, so this is, as you can see, the pressure is inside of a mesh is increasing, and along with the pressure we can also play with the wrestling scale value of our cloth constraint. And there are two methods that I'll show you to create the effect that I have created in the preview, as you saw. And one of them is going to be the wrestling scale by increasing the wrestling scale value of our cloth constant, and the other method is by creating some more pins here. So let's work on that now. As you can see, the constant is working, so we can move ahead now.